Hi everyone, let's do an example problem that involves an object floating and an object sinking and everything in between. So Archimedes principle. A 0.5 kilogram cubic block of wood, its density is given, is floating in the water. What percentage of it is submerged? Now this looks like a really tricky question. It's not so bad once we get into it, but if we're not paying real close attention, we start to do a lot of math. So I'm going to look at this thing. My block is floating in the water. And what I know, if this thing is going to float, is the buoyant force, FB, is equal to its weight, mg. But the other thing I have to know, and this mass is, okay, the other thing that is true is this is equal to the weight of the displaced fluid. So this would be whatever volume, or okay, so mass of the fluid times g. Those two things are the same. Now remember, mass is actually pretty closely related to density because density, rho, is equal to mass over volume. So check this out. I'm going to do a substitution here. So mg, I'm going to replace that m with rho v. But I've got to keep my subscript straight. So this is FB, buoyant force, is equal to the density of the block. So I'm gonna start throwing on that subscript b times the volume of the block times g, and this is equal to the mass of the fluid. This is the displaced fluid, so I don't know what that is. I'm going to call it v times the density of that displaced fluid, or Vf, sorry, which is rho f, also times g. Now I want to know what percentage of the block is submerged, so how is the volume displaced compared to the volume of the block? Well, I don't really care what this is then, so I'm going to go ahead and I'm going to divide off g because it's on both. So what I have is the density of the block times the volume of the block is equal to the volume of the fluid displaced times the density of the fluid. Now, I actually know the density of the block, and I know the density of the fluid. The density of the block is 600 kilograms per cubic meter. The density of the fluid is 1,000 kilograms per cubic meter because it's water. So if I want to know what volume is submerged, I can find that because that's the volume of the displaced fluid. So all I have to do is divide rho f, and so what I have is the density of the block divided by the density of the fluid times the volume of the block is equal to the volume of the displaced fluid. But I don't really want to know the volume of the displaced fluid. I want to know what the percentage of the block is underneath, which means I want to know what's this volume compared to this volume. So I'm going to divide by VB, divide by VB, and what I get is the density of the block divided by the density of the fluid is going to give me the ratio of the block to the ratio of the displaced fluid. So all I have to do is take the 600 divided by 1,000, which is 0.6, and I want to know that in percent, so times 100%, and I get 60%. Okay? 60% of this block is submerged. All right, now the second part of this problem is a little bit different. It says, okay, a copper weight is placed on top of the wood block, causing the block to sink until the top of the block is even with the water surface. What is the mass of the copper? So again, I'm going to start with my picture, but this time my block is entirely submerged, and there's another little block on top of it, a copper block up here. Now, just like before, this is at rest, so Newton's second law is net force equals mass times acceleration, but this is zero, it's not accelerating, so the buoyant force acting up is equal to the mass of the block times g pulling down plus the mass of the copper times g pulling down. So if I was drawing that over here, I'd have mbg, mcg, and then finally the buoyant force acting up. And those three forces add up to 0. Well, I know actually what this one is because I know the mass of the block and I know g, so I have 0.5 times 9.8. And if I knew this, then I would actually also know that. Well, I actually do know the buoyant force because remember the buoyant force is equal to the weight of the displaced fluid, or the mass of the displaced fluid times the acceleration due to gravity. Well, I know how much mass is being displaced because I know the volume. Because remember, this is volume times density times g. So the volume is the volume of the wood block, which is given by 0.5 divided by 0.6, right? Remember, volume is mass divided by density. So if I take my 0.5 divided by 0.6 times 9.8, I know what the mass of the displaced fluid is, or the weight of the displaced fluid. So 0.5 divided by 0.6 is 0.833333 times 9.8, 8.16666 newtons. Okay? So that means I can plug that in right there. 8.1666 newtons equals 4.9 plus mc times g. So minus the 4.9 from that. 8.166666 minus 4.9, and then divide by g, 9.8, and we get a mass of 0.33333 kilograms.